Hi, welcome to Voxeljet's company presentation. We are an industrial 3D printing company with a focus on the foundry industry. We are based out of Germany, established in 1999, 4 locations across the world: Germany, USA, India, and China. We have more than 20 sales partners across the world and over 250 employees. We boast of the largest 3D printing sand system in the world, the VX4000, that can print 8 cubic meters of sand molds and cores in a single cycle. We have over 430 patents in the field of additive manufacturing and over 400,000 liters monthly printing capacity from our service bureaus in Germany, US, and China. We've been publicly traded on the NASDAQ since 2013. What really sets us apart is our productivity. We believe that that is our strength. Apart from that, with the Voxeljet 3D printers, you can print in various materials. We have the largest size 3D printers on the market today with the highest speed, of course, that leads to productivity. And this also leads to highest possible cost efficiency or optimized cost of production from 3D printing. Some of our notable customers are BMW, Volkswagen, Daimler, MAN, Porsche, Nemak, Zublin, and many more. We cater to customers and markets in foundry, automotive, reverse engineering, aerospace, pumps and heavy industry, architecture, art and design, as well as film and museum. To run through the process of our 3D printing process, I'll just play a quick video for you. Just a minute. I believe the video is not playing. But just to give you an idea of what our technology, yeah, you can a quick look at
Voxeljet presents the chemical 3D printing process, powder binder jetting. The 3D printing process runs on all available Voxeljet printing systems with a variety of different particle materials such as sand, plastics or freely selectable powder materials. The only requirement is CAD data of the part. The process starts with the application of the loose particle material to the building platform by a recoater. Afterwards, the print head applies the binder selectively at the areas where the future part is to be produced, thus connecting the layers. After the binder has been applied, the building platform is lowered by the layer thickness. This process is repeated until the part is completely finished. The unprinted particle material is removed after the printing process. The models can be used directly for metal casting or as design and functional models without time-consuming post-processing. Find out how Voxeljet can optimize your production.
So that's the 3D printing process from Voxeljet, powder binder jetting. As you can see, with our technology, there is no need to make patterns, tools, and dies. Complexity of the part is not a constraint, and hence this technology saves time and reduces production costs. Some of the materials that we can print with: the sand for sand casting molds and cores. Plastic, these are models for investment casting. We are also now into high-speed sintering, so we now 3D print with polyamide 12, polypropylene, TPU, EVA, etc. And we can also 3D print with ceramics. These are cores for investment casting process. A quick look at the investment casting process with 3D printed patterns. So you would ideally 3D print a pattern from the CAD data, then go through the shelling and the burnout process as you would in your regular foundry process, have the finished mold. You would autoclave or burn out the pattern and pour the casting. As you can see, this eliminates the need to make a tool or a die for the wax patterns, which is a big advantage with 3D printing. A quick look at the process video.
Voxeljet can manufacture complex plastic parts using a 3D printing process. It consists of a powder-based process that can be used to create investment casting and illustrative models measuring up to 1060 by 600 by 500 millimeters. When your CAD data is received, it is checked and prepared for the process. Geometries can be changed at any time, as this process does not use any tools. The printing process begins when the recoater applies the PMMA powder to the build space in 100 to 150 micrometer layers. At the same time, the printer head selectively doses the binder at the points at which the model is created. The 3D printer's vertical build speed can reach up to 18 millimeters per hour. This layer building method makes it easy to manufacture complex geometries with undercuts in one piece. After the printing process is complete, the models remain in the box for several hours for hardening. Then the plastic part can be unpacked. The unprinted powder, 100% of which can be reused, is removed with an industrial vacuum and compressed air. The molds are characterized by maximum detail accuracy and precision. They reach their final strength in the furnace. For investment casting, the models are briefly immersed in wax to seal and smooth the surface. Design models are infiltrated with epoxy resin for added strength. The models are packaged carefully to ensure safe delivery to the customer. The wax-infiltrated models are processed the same way as wax models. The conventional production of complex components such as wheels is very cumbersome and expensive. Voxeljet's 3D printed plastic models provide a cost-effective way of producing installation-ready cast parts using the investment casting process, as is the case here at stainless steel expert Schmalz & Bickenbach. This wheel has a diameter of 500 millimeters. However, the Voxeljet 3D printers can also produce components up to 1 meter in length and a total volume of 320 liters. The gating and feed system is mounted after inspection. The finishing process is the same as for conventional wax models. The first ceramic coatings are applied manually, while subsequent layers are added by a robot. The plastic models soften at 80 degrees C and shrink, so that tears cannot form in the ceramic shell. Finally, the 3D printed model is burnt out from the casting die in the kiln. The plastic models burn out with virtually no residue. Now the liquid steel, which is around 1600 degrees C, can be poured into the heated casting dies. The castings are removed once the molds have cooled. Once the casting is complete, gating and feeding systems are removed, sharp corners are deburred, and unwanted surface errors are repaired. This process is followed by non-destructive tests and size inspections in accordance with customer specifications. Whether for prototyping, individual piece or small series manufacture, additive manufacturing can produce highly complex designs and investment casting models within a very short period of time.
So that's our investment casting process. As said, our technology can also be used for making sand molds and cores for the sand casting process, which takes away the need to make patterns and core boxes. A quick video also of our sand casting process.
Voxeljet presents the VX4000. A contiguous build volume of 8 cubic meters makes it the biggest industrial 3D printing system for sand molds. Its key benefits: the combination of mold and core production of different sizes increases productivity for greater flexibility and cost efficiency. The build process begins by moving the building platform into the machine and uploading CAD data. The coater is filled with particulate material and applies a precise layer of sand onto the building platform. The print head then selectively prints the binder. Each time a layer is finished, the coater and print head rise by 1 layer thickness, and the printing process continues until the components are finished. Due to the large build volume, stable sidewalls are printed layer by layer as well. They have to be removed along with the unprinted particulate material during unpacking. Learn about possible applications and how Voxeljet can optimize your production.
So that was our sand 3D printing process. As you can see, no need to make molds and no need to make patterns and core boxes. As said, VX4000, the largest industrial 3D printer on the market, sand printer on the market, which has a job box size of 4 meters by 2 meters by 1 meter. Some of our other 3D printing systems with various job box sizes, the smallest one being the VX200 with a job box size of 300 by 200 by 150 millimeters. We also operate our largest service center in Germany, which can print over 300,000 liters per month of sand and over 21,000 liters per month of PMMA parts. Some of the case studies: this is an engine block, again without the need for expensive pattern and core box, and it can be simplified into just 2 pieces with integrated gating design and ready to cast. Another example for the e-motorcycle battery housing, this is also sand casted. The entire mold was 3D printed and the complex geometry was casted in aluminum in 1 piece. This is one of our favorite art projects. It's a sling ball which has a total print volume of about 96 meter cube, a height of 4 meters. The mold was 3D printed in sand and the casting is in aluminum. The weight approximately a little less than 1 ton and wall thickness of just 8 millimeters throughout the casting. Another application for rocker arm optimization. This is for the Amazon equipments, and as you can see, earlier the component was being manufactured by welding, then the customer moved it to casting, but with the help of 3D printing they were able to change the design completely to bionic casting. The weight was reduced from 245 kgs to 200 kgs. uh, the lifetime of the part was increased by over 150%, and the time to market was just 25%. Another application for the MAN diesel engine, this is for the MAN ships. We could reduce the number of cores from 19 to just 2 cores with the help of 3D printing. Some of the examples of stainless steel castings, Francis runners from customers in India, also with 3D printed cores. Another example of investment casting, this is a really small two-stroke engine with a size of about 80 by 80 by 60 millimeters, and we can 3D print about 780 pieces of these in a single cycle on a VX1000. Another interesting example from aerospace, this is an aircraft door for Chaudière in France. The initial design, the part weighed 7.2 kgs. With reduction and 3D printing, we could bring it down to only 4.8 kgs. That's a 30% reduction in weight for the aircraft door, which is a massive reduction in the aerospace segment. Another example that we all love, this is the aircraft seat frame in partnership with Autodesk and Aristocast. This is magnesium alloy investment casting, and this is a casting that was manufactured in a single piece. Another few examples of investment casting. Also, the technology can be used for arts and crafts, and this is a large model 3D printed in sand for a customer in Germany. This is the Aston Martin DB5 that was used in one of the James Bond movies, Skyfall. I'm sure all of you remember that. And an optimized robot arm also by way of 3D printing in partnership with Technical University of Munich. So that's all. That's it from Voxeljet. Please reach out in case of any questions. Thank you very much.